Hello guys, today our topic is about the trigonometry ratios, okay? So let's move into the first part about the trigonometric ratios, okay? So here we can find there is a triangle, and here we call this opposite, adjacent, and hypotenuse, okay? So we can use a small letter, like small capital letter like H represent for the hypotenuse, the small letter, but for the capital letter O represent for opposite side, and the adjacent side A, okay? So you can find theta right here. You can find theta's adjacent is A, and you can find there's always like here is opposite to the angle theta. And here is also we have a hypotenuse, okay? So we can say that by labeling the trigonometric for the angles, we're very easy to represent for the trigonometry, okay? So here we have three part or three kind of the trigonometry. First is the sine function, okay? So we can say that the sine theta can be written as the opposite side over the hypotenuse side, okay? So maybe you can find in this triangle, the opposite side of the hypotenuse side is O over H, right? Okay, so we can say that is O over H, the side O over side H. And here we have cosine theta and trigonometry, we can say it equals to adjacent side over hypotenuse side, okay? So we can say here, adjacent side maybe is this adjacent side, and this is for hypotenuse side, okay? So we can also written that as A over H, okay? So here is for A over H. And tan theta equals to the opposite side over the adjacent side, okay? So opposite over adjacent, that is here, opposite over adjacent, okay? So we can read also written as opposite over adjacent side, okay? And for example, like here, it's a problem asking you to finding the length of x, okay? So you can find here is 8 centimeter is the opposite side of the 35-degree angles, right? That is opposite. And x length here is for the adjacent side, right? So you can find we knew opposite and adjacent. We can just try to draw the graph. That is for opposite over adjacent. That is for tangent 35 degree, right? Okay. So we can say here that is tangent 35 degree can be written as opposite side over the adjacent side, right? That is for 8 centimeter over the x centimeter, okay? That is for this formula. And we can say here that x can be written as 8 over tangent 35 degree, okay? That is for this problem, okay? So that is for the x value, you can just calculate this as 11.4 centimeter, okay? So you can use a calculator to calculate this, okay? And for the next part, like finding the unknown side, like y, this is a hypotenuse side y, right? So here you have 550 degree. Here is for the adjacent side 7 meters, and here's y meters, okay? So you can just try to draw like 7 over y equals to tangent 50 degree. So y equals to 7 over tangent 50 degree, okay? Sorry, cosine 50 degree is not tangent, okay? So here is for cosine 50 degree. So you can just use the calculator to calculate 7 over cosine 50 degree, okay? And for this problem, if you want to calculate angle theta, you can say, maybe you can find here, theta's opposite side is 5 and the adjacent side is 4. That is for tan theta equals to 5 over 4, okay? So you can say like theta, you can just use your calculator to calculate that's tangent -1 5 over 4, okay? So this means that this we can say that is a reverse function, okay? So you can just call it value of the theta, okay? And maybe for the deliberate practice for you, if you want to try yourself, you can just pause the video and do yourself. But if you want to keep on going, you can just follow with me, okay? So let's go to the first part about here. In the triangle ABC, angle B is 90 degree, and here we have angle A as 25 degree. This is A, this is C, 35 degree. So the angle, the side AC can be written as AC, and we knew BC is 12, right? So that is for 12 over AC, that is for sine, because it's opposite side over the diagonal side or hypotenuse side, right? That is for sine 25 degree. So you can set AC equals to 12 over sine 25 degree, right? That is for first problem. And for the second problem you can find here is that a right angle triangle has an opposite side of 15 meters and a hypotenuse of 25 meters. Okay, so you can set here maybe opposite side is for 15, hypotenuse is for 25, and just you can calculate the angle theta, right? So just trying to find that the sine theta equals to the opposite side 15 over the hypotenuse is 25, right? That is 3 over 5. You can set the theta approximately equals to 37 degree. Okay, that is for second problem. And for the third problem is that an aeroplane takes off at a constant angle 14 degree to the horizontal. Okay, so that is for the degree 14 degrees. Okay, after flying for 2,000 meters along the flying path. Okay, and what is the vertical height above the ground? Okay, so you can set that using the trigonometry. You can set that h over 2,000. That is for the 14 degrees opposite side over hypotenuse. That is for sine 40 degree, right? So finally, you can calculate as h equals to 2,000 times sine 14 degree as our final answer, okay? That is for problem 3. And for problem 4, we can say here, the sine 40 degree equals to 10 over h, okay? So if you want to calculate it, so you can just say like here, this is 40 degree, here is 10, and here's h. And we want to find the another side a, and we can using Pythagoras theorem, okay, as that square root the h squared minus 100, right? Using the hypotenuse side squared minus adjacent side squared, okay? That is for this formula. Okay, so that's for this our lesson. We already learned about how to just trying to using trigonometry to calculate for such problems. Hope you can understanding for how to use them. Okay, so see you next time. Bye.